Me again. So I was asked to introduce our first keynote speaker because we've been friends for many years. But that isn't actually entirely accurate. So illustrated by something that happened 3 or 4 years ago, where Hynek introduced one of my talks at PYCON Italia and warned an entire audience of people to ignore everything I was about to tell them. Hynek and I have actually had what Hynek describes as a hateful friendship for 14 years, where I more simply describe us as enemies. You may know Hynek as the author of the very popular ATAS library, which is the second most popular third-party data classes library. So for reference, for the people who didn't quite get that joke, data classes in the core Python library was actually based on ATAS and is essentially a re-implementation of it. So Hynek does occasionally have some influence on some quite important things that affect us all. He's also the author of the services library, which makes a lot more sense when he says it out loud. Structlog, Stamina, and a bunch of other libraries, but probably more well known for his blog, his newsletter, and the YouTube channel he would desperately like you to like and subscribe to. I would like to say that you should ignore everything that Hynek's about to tell you, but sadly I can't. One of the most infuriating things about Hynek is he quite often talks a lot of sense. And so, in fact, I'm going to have to recommend that you listen to every word he said and think about it and maybe talk about it with other attendees afterwards. I have already read through all of his slides twice, and it's given me a lot to think about. And so it is, in fact, my greatest pleasure to ask you to give him a warm welcome. This is Hynek Schlawack, who is going to give us our first keynote talk. Thank you very much.
All right, sound check from my Napalm era. Okay, it works. Okay, so I couldn't hear what he's saying because the soundstage is the way. I just assumed that he was mean as always, and nothing he said is true. Also, I've noticed I'm starting late, so that means by the laws of this country that I can talk as long as I want because the order has been destroyed, so I can breathe between my words. Also, sorry, Julia and Joanne, this is gonna be fast anyway. So, what I'm gonna talk about. For dramatic reasons, I will start at the rock bottom and talk about how Bluetooth takes a moment to program, how Python almost died. And I swear this is gonna make sense at the end. And I'm very lucky because thanks to the Python documentary that just dropped on YouTube and that you should all watch, not now, but later, I can be really brief. And what I'm going to talk about, of course, is the Python 2 to 3 migration, which started in 2008 with Python 3.0, which wasn't even really intended for general consumptions. It was more a demonstration of the aspirations and a request for comments. Python 3.2 was like the first one where Guido just started pushing us to actually use it. And then, as shown in the documentary, a pretty dark time followed. The main change was that Python 3 switched up how a very important data structure is handled, strings, switching from the native and default type from machine-friendly bytes to human-friendly Unicode. But that alone wouldn't have been that of a big deal. What it also did, and that isn't mentioned in the documentary as much, is that it removed a lot of implicit behaviors that many developers depended on, often by accident. So, for example, you could totally compare strings and numbers. You would get nonsense results, but it worked, it didn't crash, which leads to very nasty bugs that are very hard to debug because it just silently passes. And in Python 2 times, you could tell if a package is from an English-speaking programmer because they would routinely explode into our faces with Unicode decode errors, and that's because when you somehow combine bytes in Unicode in Python 2, like with the format here, Python automatically tries to decode the bytes as if they were 8-bit ASCII. That means this works exactly as long as some user input doesn't bring something that is not from A to Z, which happens all the time in the rest of the world. So Python 2 code bases were full of minds like this, and Python 3 clearly changed to the better. Python 3 was good. It was a lot more explicit, and it was a lot more international. But porting an entire ecosystem was not. This transition put an incredible cost on the community. PyPI back then was a tiny fraction of what it is today, but it was still a lot of software to be ported. In addition of the actual code we had, or have, in production. As part of writing this talk, I've ported the last Python 2 applications that was still listening on the internet. So it's such a miracle we didn't get owned for that. So, software that usually didn't have the test coverage that we take for granted today, because it was just not as culturally ingrained. I mean, maybe Python's testing culture is a result of the whole Python 2 to 3 migration fiasco. And PyTest wouldn't be as great it is today without. I mean, that's a good topic for sociologists. And on top of that, there were types of applications and packages that were a huge pain to port. Those that lived at the boundary between bytes and Unicode, which includes everything that talks directly to the network, including web frameworks, and a Q said Armin Ronacher, who ended a bit with the role of the heel in the documentary, but he was actually instrumental for Python 3 to happen in the end. And it also didn't help that there was a language moratorium between Python 3.0 and 3.3, which meant that the new language that was perceived as painful to support had precious few new features. So it was like very little motivation to actually go there. It was all stick and no carrot. Or as Armin said, why are we ruining all of this with this move that didn't have that many benefits? But the main problem was not that we were unmotivated or lazy to do the work. It was that such a transition was unprecedented before anything was unprecedented. So we didn't know how to do this. Armin alone wrote 2 blog posts about how to port your software from 2 to 3. It kept being a moving target for years until 2012, which is 4 years later in Python 3.3, where we finally agreed on how to do it, hybrid code bases that ran both Python 2 and 3, and we had all the tools that needed to do it, notably the package 6, that, by the way, is still in the PyPI top 20 download charts with 500 million monthly downloads, and explicit U prefixes for Unicode strings in Python 3, which allowed us to write strings the same way in Python 2 and Python 3. And that's, again, 4 years later. And for those who were there, was this issue settled in 2012? Sad laughter, yes. No, for at least half a decade, it was unclear whether Python 3 will even become the dominant Python version, or if all the work we've done will end up as a huge waste of time. Around the same time, Perl tried a similar thing. They wanted to modernize themselves, be more object-oriented. And it was called Perl 6. How many people are writing Perl 6 nowadays? Nobody. People who like Perl write Perl 5.42, and Perl 6 has gone on to become a new language called Raku, which, as far as I know, has a rounded number of users of 0. And there was always the possibility that the same thing is going to happen to Python. So either because the core team just gives up on Python 3, or because someone forks Python 2. Because it's not as a big deal as it used to be, but PyPy used to be a huge deal back then. Like every Python conference had a great PyPy talk that promised a great future. And it felt like choosing between fast and modern when deciding which one to use. Because they were Python 2 only for a long time, and are still, because they don't have as much people power or lagging in the Python versions. So there was another conflict on top of what we had. So this phase lasted until, like, in my opinion, 2016, when it finally became clear that people increasingly started new projects in Python 3, as corroborated by Andre, who at that time worked for PyCharm. But even then, like the package downloads using Python 2.7 still reigned supreme. It was only the trend that gave us the hope, not the state, not the situation. And this was another 4 years later, after we had everything we needed. And these numbers sound harmless, like in retrospect, like when you look at history, so something took 20 years, who cares? But when you were there, that was 8 years, a long time. Like, especially when at least half of it, you were agonizing over the future of your favorite programming language that you built your career on. Like, people nowadays cannot even comprehend how that was. It was very stressful. And it still wasn't over. Not all packages were ported yet. And Python 2.7 was supported for another 4 years by the core team. The last Python 2.7 release was announced with a hand-washing joke because it was freaking April 2020. Almost 12 years after Python 3.0. 12 years of thrashing and churning, arguing and fighting. And sometimes we call this the lost years, but it's more of a lost decade. And There is no doubt that the Unicode Band-Aid had to be ripped off for the language to be relevant in 2010s or even 2020s. But it cumulatively absorbed thousands of hours of work for this to happen. Hours of work that could have been used to write cool new features, remove the GIL, or fix packaging, which is happening now, 5 years later, so it's basically the same time. And I still run into people who are extremely bitter about the whole thing, how it went down. The community lost many good people over that, and burned a ton of goodwill. And I'm not bitter myself, despite being on both sides of this whole thing, but I really hope that we as a community never forget what happened there. Hashtag foreshadowing. But in the end, we somehow made it. Why? Was it community? Today it's always community. But back then, we were kind of busy with infighting. Like, it felt a bit like a first instance of what has become the culture wars that we are having nowadays, because there was a lot of posturing. If you like Python 3, you didn't criticize it. And if you hated it, you couldn't say anything nice about it. People literally wore these t-shirts at PyCon US. I got this photo from Alex Gaynor, who just refound it because of the documentary, because like everybody's like, oh my God, remember the time? Yeah, Pepperidge Farms remembers. So no, the reason is a lot more prosaic. We made it because we had a higher influx of new people than we were bleeding to Node, Go, and Rust, who were taking around the same time. Like, that was a very vulnerable time for Python. So we might have been a leaky bucket, but the fire hose was strong. And now, as is shown in the Python documentary, Python was always used by scientists and engineers. The first NumPy version on PyPI is from 2006. But the roots of the project go all the way back to 1995, where many, if not most of you, weren't even born yet. But in the mid-2010s, I knew science rose to prominence, and it keeps rising until today. Now, more than half of Python users use it for data exploration and processing. And anecdotally, I can confirm that too. Like, I keep running into people who use Python for these kind of things at my gym. And usually those aren't self-described programmers. It's mostly managers who try to get insight in some data, or of course, automate Jira. Yeah, painful laughter. So there's a lot of reasons why a survey run by an IDE company that we all love because they're sponsoring this wonderful conference, or my survey of my gym bros and gym sisters might not be the perfect representation of the whole Python community. But it is an important signal viewed over time. And 2024, because the questionnaire for the 2025 was in 2024, it was the first time the data science cracked the 50%. While the community kept growing like was. So it's not just like erosion of the other users, it is like legit, it keeps growing and growing. And the constant influx of new people is true to this day. So the joke that the average Python programmer started using it last week is not far-fetched. And given these numbers, hands up if you've ever written Python 2 code. Okay, it's more hands than I thought. Hands up if you ever thought about Python 2 at all. It's less hands. That's, I think that's called denial. But still, this is such a grandpa talks about the war situation, because when the documentary dropped, so many people, including Alex Gaynor, who gave me the t-shirt picture, were like, oh my God, yeah, it did happen. Oh my God, it was really bad. But it is really over now, and this is so good. Like, it just faded out of our consciences. So the thing is that Python 3 obviously is the better language in every way. And those new people coming in the late 2010s had no nostalgia for Python 2 whatsoever. They didn't have tens of thousands of lines of untested Python 2 code. So why would they start on Python 2? They didn't. And the scientific community was also the first one who politely informed the public that they do not plan on supporting Python 2 much longer. And maybe not this statement specifically, but this attitude by the scientists definitely moved the needle towards the acceptance of Python 3. And this is good. But while it explains why we survived, it doesn't explain why they came to us, like why we were struggling to decide on our own future. Why didn't they just go for Perl or Ruby? And obviously, the main reason they came is the existing ecosystem. This is just a tiny fraction that I could think of, and I'm very much not a scientist. But why does this ecosystem exist in the first place? And my understanding is that one reason is the ease of making Python interact with other compiled languages from the very, very beginning, which also cursed our packaging story forever, because you don't have a solution to Python packaging unless Fortran has a place at the table. But Fortran or C++ aren't much fun to tinker with. Meanwhile, Python is perfect for exploratory programming, which I'm hearing is kind of important if you're trying to figure something out. Lisp fans will not shut up about how great it is to develop in a REPL, which is short for read, eval, print, loop, which is basically just an interactive shell inside of your programming language. And Python has one built right in. And if you like it fancy, you can say hello to IPython or even Jupyter. And I cannot prove it, but I'm 100% sure that Jupyter Notebooks is what sealed Python's ascendancy in the late 2010s. And this, of course, is not just about science, because I also love the REPL, and I'm not curing cancer, especially now that it has been replaced in Python 3.13 and keeps getting much faster, better and better and better, because it's not a huge pile of gnarly C code anymore, because we stole it from PyPy. Now, we are even getting syntax highlighting in Python 3.14 in PDB. I did never think I'm going to live to see that. This is so beautiful. And PDB is like one of my favorite features of Python, because it allows me to drop into Python's REPL anytime, and I can just interactively poke around. Because debugging is all about building a mental model of a system and then verifying your assumptions. And everybody's brain prefers a different way of model building, but for me it's like futzing around in a REPL and poking at objects and see what happens. And I also absolutely love that the breakpoint thing is just a Python function that will drop me into a configurable debugger, so I can express the condition under which I want to enter the debugger using Python. Like other languages and debuggers tend to have complex mechanisms on how to create watch points and breakpoints and whatnot, special syntax, thick manuals. We just write if something, then breakpoint, and it's done. We don't need special features or clicking around or whatever. Python is perfectly capable of expressing conditions, so let's use them for entering our debugger. And the breakpoint function, I wanted to say it's new, but it's not new at all. I'm just very old. But it works with IDE debuggers too. So many users who use breakpoint don't even know PDB exists, and it doesn't matter, it's fine. So I might be projecting, but I strongly believe that experimentation through short feedback loops and good introspection is the best way to explore a problem, whether it's a bug in a web service or anomalies in scientific data. And Python has very fast feedback loops. But this is not a superpower. I promised you a superpower, but this is not one. Lisp has been offering features like this since the 1950s. And if you want to science around, there's languages built specifically for sciencing, like Julia, R, or remember MATLAB? But Python beat them all. Like, why? Firstly, it's open source. That certainly helped against MATLAB, which used to be obscenely expensive and still is compared to free. But I think it won mainly because it doesn't stop there. Python doesn't stop there. And now we finally do enter the superpower territory. So scientific programming has long suffered from the two languages problem. It basically says that first, you use an easy, usually dynamic expressive language to prototype a solution, and then you re-implement it in a faster, more rigorous language, C++, for example. And the Julia language declared solving the two languages problem specifically to be their mission. And Python never set out to solve it. Python is older than the formulation of this problem, I think. So we just somehow did it by accident as far as the core community is concerned. But is Python fast? No, it's not. Despite all attempts, it's not. But scientists found their way to use Python as a glue between high-performance parts written in C, C++, Fortran, or literally Rust. And that will take advantage of every single CPU and GPU core that you might have. And peons like myself are doing the same thing. Like, I love the Rust-based Granian Whiskey/ASGI server. You might be using Pydantic, also Rust. SQL Alchemy is the best SQL toolkit on earth, and it's full of Python. And I maintain the Argon 2 CFFI package, which is a wrapper around the C library, because you don't want to hash passwords in pure Python. And finally, the biggest speed bump Python has, the global interpreter log, is slowly saying goodbye too. And we will be able to use more than 1% of our CPU cores, even in pure Python code. Wow, big success. And that's all I'm going to say about performance. I'll leave the topic to all the PhDs in our community working on it. A few of them are attending this conference, I believe, so remember to say thanks to them. What I'm more interested in is the second part, the rigor. It's been greatly exemplified by this tweet by Hillel Wayne, a software intellectual extraordinaire. But the thing with intellectuals is they use some really big words like tractability or expressiveness. Fortunately, there's a summary for dum-dums like myself, and it says, the more flexible a language is, the fewer properties are guaranteed, and the harder it is to write tooling for. Python, by default, is very flexible. And this is also a huge problem with making it faster. But let's focus on rigor, because then he goes on to say, dynamically typed languages can express types in statically typed. That statically typed languages cannot, sorry. But you can't, well, type check them statically. I totally can type check my Python code base if I choose to sacrifice some dynamism. In other words, with modern Python, you can have both. You don't have to rewrite your app in Fortran. Instead of two languages, you can have one language with a spectrum of rigor. And I could throw my computer out of the window when Go refuses to compile a file because it's an unused import or an unused variable or something like that. In Python, I can make Flake 8 or Ruff yell at me about those things too, but only if I've chosen to step up my rigor levels, not while I'm experimenting, not while I'm trying to understand the shape of my problem. Until then, Python will run anything it can parse, with extremely helpful error messages along the way, and I hope you've noticed that they've become a lot better in the past releases. But rigor is not the only spectrum that Python offers. There's a clear path in Python from curing cancer in Jupyter notebooks to exposing your science to the wider world using a website or web service. And this is 100% the reason why Fast API is such a huge success. The fast does not refer to performance, it's still Python. Fast API is not fast. It refers to how fast you can get whatever you've cobbled together online. That's the fast part. Oh, sorry. That's the reason why investors ranked a cool $4 million on Fast API Cloud. And I assure you, it's not because they think we are going to build Stripe or GitHub with that. It's adding easy cloud hosting for the web framework that makes it easy to expose something, even if you're not an expert at web, is the logical next step here. This is a huge market in Python. And there's no such thing in MATLAB on top of the fact that the license is 500 quid, even with educational discount. So the superpower I'm talking about is graduality writ large. With Python, I can start by cobbling together something in the REPL that would make Donald Knuth cry, move to Jupyter for graphs and rainbows, add a bunch of linters, auto-formatters, tests, type hints, and finally deploy something maintainable either as a CLI command, a hosted Jupyter notebook, a web application, or whatever kids these days do. And everything along the way is just Python. I can run it. I can iterate on both the rigor and, let's say, the medium of the software, and also on the complexity of my design. Or to put it more tongue-in-cheekly, you can start with the crown jewel of Lisp, the REPL, and end with the pride of TypeScript and Rust, static types. Now, is our REPL as good as Clojure's? Probably not. Is our type system as good as Rust's? Even asking that is heresy, and the crabs will eat me at night. But that is entirely in line with Python's unofficial motto. We're the second best language for everything. I swear to God, I'm going to topple the thing. Okay. While the implied number in second is not to be taken literally, you nerds, it is true. Like, we've built a company around that. Like, we're a small company, we're like 10 people, and we use Python for everything. And there's a huge difference between a network server, a web service, a website, an automation script, discovering black holes, curing cancer. But the sheer fact that we can use the same language underneath for this all is nothing short of fantastic. So Python superpower is not just that we have a low barrier to entry. There's a lot of languages that do have that. But also that we have several high ceilings that you can choose depending on what you need. And man, I've been waiting to air this on stage for at least 3 years. Also notice how whatever I've been quoting has been deleted. One of the reasons why I started thinking about this in more serious ways is that Twitter was full of arguments about how some feature is ruining Python. And I disagreed, and I still do. Usually it's typing, sometimes it's async I/O, and other times it's some new feature people hated so much that Guido rage quit from his BDFL post over the abuse he received. So, and I swear I had receipts. I did have them, I took notes, but they did not survive the fascist takeover of Twitter, so you're just gonna have to believe me. Now, this conversation is not over yet. At the CPython core panel in EuroPython this July, someone asked, aren't we afraid to fragment Python? We have async Python, regular Python, free-threaded Python. Which Python is the real Python now? And Hugo, who is in this room, answered it all with a beautiful, pithy, all of them. And he's right. And I want you to embrace the fact that all Pythons are beautiful. Async Python might become less relevant if we actually get virtual threads, which would be amazing. But still, we have learned our lesson, and our approach to everything is very gradual. I mean, if you saw the process of even of the free threading thing, how it was accepted, it took years and discussions and everything, and we were always so afraid that we got into another 2 to 3 situation. Now, I also think it's very good that we are adding more gradients. I'm on the record of saying that I would have left Python long ago if it hadn't added static typing, and I mean it. I cannot imagine to dive into a code base after a year or so without proper type annotations anymore. And I also love how my code style changed when using static types, because well-written Python code that uses static types looks very differently than a dynamic style of Python code. It's not just the same code and you sprinkle types on that. It's a completely different style. Sometimes people call it like the Rust style that Python has moved there, and I love it. I'm here for it. But if you don't want to, if you don't love that, if you want your command dispatch thing or these nice things, or if you buy into the excuse that type hints are somewhat only for big teams or whatever, nobody's going to force you. Nobody's going to force you to use static types on your throwaway script. But you and I can use the same language. We can use the same test runner. We can use the same HTTP client. We can use the same IDE, sponsored by PyCharm. Your level of rigor and complexity is your business, and mine is mine, and Python will just play along. And of course, the best Python speaker of all times put it much pithier than I will ever be able to. Python lets you walk before you run, before you fly. Thanks for the goosebumps, Brandon wrote. He was talking specifically about the graduality of the concepts that you need to understand to write certain types of Python and the progress of your skills. But it's exactly my point. We have graduality everywhere. We just pick people up very low and we carry them very high. Now, full spectrum of rigor can be expressed less charitably that Python allows you to write sloppy code and it somehow works. And that's great, as long as you have a way to verify that it does what you want it to do. In the beginning by hand, later automatically. And who else writes sloppy code and is useless if you don't guide and verify? It's our friends. The large language model chatbots, also known as stochastic parrots. I don't think it's controversial to say that the tolerance for sloppiness is a big reason that makes Python a primary target for LLMs and the agents that are based on them. And if you watch them work, you can tell how they slowly work up their rigor ladder. Like first they've got syntax errors because they mixed in some Python 2 for whatever reason. Then there's a failing test, then there's failing linters, then there's failing type checks if you have types. And I find it kind of cute how vibe coders are discovering good practices like version control to easily revert slop, writing tests first to keep their chatbots on track, and proper backups for times they leave their tracks anyway from first principles. By first principles, I mean catastrophic data loss. I'm sure you saw this floating around where Replit dropped some dude's production database. And this is really not my topic today, but I used to talk a lot about DevOps topics. And let me tell you to not give the stochastic parrot keys to a production database. Like, read access is bad enough since it might inadvertently siphon off some delicate customer data, but write access is just negligent. The system prompts for these LLMs are hilarious to read if you get to read them, because they are literally begging them to be good boys, and yet this happened. Because there's really no way to stop it, because these systems are non-deterministic, and they are not deterministic by definition, so they need guardrails to be safe and useful. And we've got some great optional guardrails in the Python community that we can employ whenever we are ready. They are called PyTest, Rough, Flake8, Pyland, MyPy, Pyrite. Oh my, we are ready for the sloppy future, my friends. Now, all this sounds great, but it opens the question, is graduality always good? Does this coin have another side? Can there be too many gradients for something? And Mr. Betteridge can take a hike today, because we are now getting to the spicy parts. Yes. So a very unoriginal observation I've made is that whenever we add a new feature or a special case to a system to make something easier to individual users, we risk raising the overall complexity of the whole system that everyone has to deal with. In this case, the system is the Python ecosystem. So it's really important to be conscious of the trade-offs we are making here, because it affects a lot of people nowadays. And I'm sorry for people who came to my previous talks, but it's time to beat the simple versus easy drum again. Yes. So people will usually say they want simplicity. It sounds so good. Nobody ever said, oh, give me something complex or complicated. No, they say they want simplicity. What they're actually asking for is ease. They want to follow the path of least resistance from wherever they are right now, even if that path leads them into some corner where they paint themselves into, and they will need more features and more special cases to keep going later. And I guess this case, the gradual doesn't go vertically, where you add gradients on top and it doesn't affect the one at the bottom, but horizontally, where you add exceptions and special rules that everybody has to know and implement. So again, guardrails are good. And when you add more exceptions and special cases to a system that makes certain things easier in the short term, but they make the system harder to understand and more complex in the long term, you're basically growing a sprawling tower of shit that everyone has to deal with to save someone some key presses. Because, and I cannot stress this enough, complexity is not the number of keys you have to press to achieve something. It's not complex to press keys. Gravity will do that for me. Code will do that for me. Codex will do that for me. Pressing keys is easy. Complexity is about how difficult it is to reason about the systems that we build. How much cognitive load does it take to understand the result? Do I understand it at all, or is it working by accident? Even the Zen of Python asked us to be explicit. So as Pablo Galindo sagely said on his Python comedy podcast, you bought a mechanical keyboard, use the fucking thing. They work really hard for the explicit label. So, now this sounds all a bit abstract. So I'm going to give you an example from everyone's favorite topic. Packaging. I was considering to get like a tire fire, but so due to historical developments, and I need to stress I am not throwing shade on anyone in particular. It just happened, as things do, in a larger context of history. And it's actually useful that I can use a concrete example without throwing anyone under the bus. So we have roughly two ways to structure Python applications. Either the ad hoc way, where a Python interpreter just auto-discovers code laying around like this or that, and guesses itself through a bunch of import heuristics how it's going to just use all that. Or as a package that is much better defined by a bunch of PEPs and has relevant tools built right into the standard library. Now, the src directory is optional, but I've been once called to be famous for advocating for it, so I cannot miss this opportunity to shill it. It prevents me from importing le package without, I didn't know I'm going to have French guys in the first row. Without installing it first. Usually by running pip install -- editable period or just -e period. And this means install this project, but in a way that changes to the project directory are directly reflected in an installed package. And this is another layer of guardrails that protect me from surprises in production by being more strict in development, or as the cool kid says nowadays, shift left. And of course, the ad hoc way is way older. It harks right back to Python's origin as a scripting language, so they came first. We've gone from having like one script that you run by passing the path to Python and started allowing more and more complicated setups around that, ending up with a sprawling landscape of possibilities of what a Python application can be. And unfortunately, over the years, as we've evolved our tools and standards, we've missed the boat of putting guardrails around the concept of what a Python application is. Not a Python script, a Python application. We never told people that a Python application should be a package because it has these upsides. And we didn't even give them the documentation and tools to make that easy. Instead, we've made like this every effort to keep everything weird in between working that somehow accumulated over the decades of Python's existence. And we didn't dare to at least discourage it. And the thing is, we need packages for installable packages. So we are not choosing between packages and ad hoc projects. What we are doing is deciding how much support are we providing to a completely optional concept, and what cost is it incurring on us. So I don't think we've done anyone a favor by growing this particular tower of shit. We could have let it to be just much smaller turd to start out, and spend the same energy on making the good way, also the easy, viable, and straightforward way. Because my message is not get good. My message is, let's solve this properly, let's make it simple, let's make it easy. And find out why people don't use the good way and help them. Maybe make it more attractive, but don't make the ecosystem, don't make them pay for like a temporary comfort. And whenever I bring this up, and some of you are already like all twitchy to say it, I get asked, what are the upsides of packaging your applications? Why is it a good way? And I will give you one big reason, but ultimately it's completely beside the point, because the problem is that no such thing as an ad hoc layout exists. It's just an infinite shapes that are accidentally supported by a bunch of rules that nobody quite understands. And you really don't need to know how to split an atom to package your app. Like, you just need to know that you need to install your package into the virtual env along with its dependencies. And now your app is an official part of the virtual env and is treated like any other package. There's no need for guessing or workarounds to find your code, because your code is right there. And when Python does the same thing to your code as it does to Django or Pandas when it's trying to import them. And that makes the behavior a lot more deterministic, understandable, and therefore simpler. And a similar case and pet peeve of mine is pip install -- user. It allows you to install packages into your home directory, making it look like as if the package was installed globally. And if I had a nickel for every time someone opened a bug in one of my too many Python packages that was caused by some stale dependency in their user local global scope that they forgot about, I would have arrived on a private jet and were taken by a helicopter to the venue. I did not. I was stuck in traffic on Princess Roadway like everybody else. By the laughter, you know who's local. So adding another global namespace makes never anything better. And to me, this is the ultimate Python packaging attractive nuisance. But sadly, I have only 1 hour of the time, so I can't air all my grievances. And I had to like delete like 10 slides on this topic around. Like Mark knows it, he saw them. But come to me and talk to me after I had a beer. I got a lot of material in my back pocket. I'm so much fun at parties, I don't understand why I'm forever alone. So now, instead, let me show you the price of this over-indexing on making everyone happy. And I'm going to use the beloved testing framework PyTest to show you, because it has a whole page explaining how it handles sys.path, which means how it imports your tests and what side effects its methods have on finding packages elsewhere. And they can be in the virtual env, they can be in the global Python installation, they can be in the per user side packages, or they can be just laying around in the current working directory, just put there somehow. So PyTest tries to be smart about that. And that bit me just the other day. I'm not making it up. It's like a week ago when this bit me, because the default setting panders to ad hoc projects and tries to guess. So suddenly a botched VS Code autofix that just Cthulhu knows why prepended my import path with SRC, which does not work, obviously, worked locally because PyTest just inserted something into the Python path and it broke production. And to me, this is the worst case failure that I'm doing everything to prevent, and yet these rules are so complicated that I tripped over them anyway, despite writing Python for almost 20 years and using PyTest for another 10. But this chapter, if printed, is 3 A4 pages long, so it's kind of easy to miss something. And they are by no means perfect, but we know exactly what a Python package is. We have standards, we have tools. They are explainable. We know how to find them, we know how to install them, and we know how to use them. Virtual envs are also well-defined and predictable. And they are the closest thing we have in Python to a dynamically linked, isolated, self-contained application artifact. And the amount of energy that went into avoiding to use them, and -- user is one of them, for minuscule upsides has also had similar costs that ripple through the community. And we could have just used that energy to make virtual envs better and faster, and I don't know what's missing. Meanwhile, over the years, the tune of the criticism of Python packaging changed. It wasn't focused anymore on the tools being bad, like building paints of GPU-dependent C++ Fortran contraptions aside that created a business case for Anaconda, so good for them. And no, the tools were good for like a decade. Pip works great. A slow but correct virtual env is in the standard libraries since Python 3.3. And PDM has been working great for me as a project workflow tool for years. No, the main criticism is that when you arrive in Python land, you must make way too many decisions right away for which you are not equipped yet. And everyone is yelling their favorite way at you. I mean, how many best practice cookie cutter or copier project skeletons are on GitHub? I'm afraid to ask how many of you are maintaining one, because yes. Yeah. And for years, people have been asking for an all-in-one workflow tool like NPM or Cargo. And it is very nice to have one now that we have UV. And seriously, it is as big of a deal as everyone says. And no, the speed is not the interesting part to the least. No, at all. So if you've been putting it off because it looks too good to be true, it isn't, go and dive into it and you will not regret it. But please don't try to use it as just a faster pip replacement. I see that a lot. I saw it this morning. I already yelled at someone. It's a huge waste of potential. Go all in on its project features and cross-platform log files. It's a game changer. Apparently, I can't talk for 60 minutes anymore without shilling UV. I should have never accepted that weirdly colored drink from Charlie Marsh. But what the people were asking for this, we're not really asking for a tool. At least I didn't know it. What they asked for is guidance and leadership. Yes, I Googled for the best example of leadership. There should be one obvious place to get your Python. There should be one obvious way to structure your application. There should be one obvious way to ship your application to production. It is very clear what a Rust or Node application is. This is still not true for Python. And this is why I got really excited when UV shipped their project workflows with no support for ad hoc projects. If anyone could carrot people into the fold, it would be UV, the first great Python packaging tool that everybody loved. This nice project workflows, people surely are gonna use packages, right? For understandable but frustrating reasons, I cannot have nice things. And they caved in and added support for ad hoc projects in the next minor release. And I was following their Discord at that time a bit, so I know they were kind of bullied into it. Whether they wanted to do it anyway or not, I think they did, but maybe not that fast. So now, when their docs explain projects, they have to differentiate between applications, packaged applications, and libraries. This is the other side of the coin of undifferentiated horizontal graduality. This not existing would be the upside if everyone just packaged the applications. Fancy people call this second-order consequences. And does anyone think this is actually good for anyone? It is clear how we got there, and it's nobody's fault in particular, but it sucks we are here, and it was not inevitable. These three things could be one thing, a package, no decision necessary. And then depending on whether it's an application or a library, you add more things on top of that, like log files, CLI entry points, or PyPI metadata. This could be purely additive. But instead, we start with a decision tree before we wrote a single line of code, and the jankier version is the default. And all that just so people don't have to run pip install -e period, which they don't have to anyway, because if they use UV, they should use UV sync and UV run, because these are applications. So you should even use these commands. Like this is so frustrating because it didn't have to happen. So I think it would benefit us all if the gradient after I've got a main.py that does roughly what I want was calling something like Python init or UV init that creates a package skeleton around it and also offers you to copy the file into the packaging directory so it can be used right away. If the tooling and documentation were clear, and this were the one standard way that everybody uses, there would be no extra complexity put on the user. But to be clear, this is not a call to action for you to go out and make everyone use packaged applications. I do not care how you handle your applications. They are your problems, not mine. But I do care about the cost on the ecosystem. And that ship has sailed. The ad hoc layout is here to stay. We've seen that from the reaction to UV not shipping it. You can't take things from people unless you have some very strong leverage. And if you have to explain why they should use something, you've already lost. This is an uphill battle, so they are staying. But what I'm asking you is to remember what these ostensible harmless concessions have done to UVs and PyTest docs. I want you to be mindful of what cost you impose on everyone and extrapolate it to the greater Python community. And this is where we tie in back to the start of this talk. The Python 2.3 fiasco was, barring Python dying, the worst possible example of a gargantuan cost imposed on the community from the top. That led to almost a decade where we spent a lot of our energy on moving the ecosystem to Python 3 and bickering between whether we should do it in the first place. And miserable as we were while it was happening, is an interesting case study whose principles work just as well in smaller scopes. So how many more blog posts, docs pages, and packages have been written because it's unclear what a Python application is? So I'm asking you to keep this in mind. Oh, God. I'm asking you, when someone asks for a special case or because something is inconvenient or confusing, just don't ignore them, but find ways to make the good way the easy way. Or to put it in other words, putting your community first sometimes means not giving them what comes to their mind first. All right. So we've got some bad gradients where we let people continue on a way against their own interest, also known as an attractive nuisance, while adding complexity for everyone else, also known as externalization of costs. And that's also a very hard word to say. But could it still be that we miss a bunch of gradients? Still a yes. Surprise. I said before that a big part of Python Superpower is that we don't have just a low barrier to entry, but we have several high ceilings. And now I want to tell you the story of this photo. It was taken after an open space at EuroPython in Prague earlier this year, and it was organized by the gentleman taking the selfie and a bunch of his buddies. And the topic was, is Python suitable for building maintainable complex software? And the stated reason for this open space was specifically that they have been made fun of by .NET and Java developers at some conference for even trying to write complex software in Python. So the whole open space was more of a therapy session about how and why so few people in the Python community care and talk about how to structure applications once you have more than a handful of views, how to build extensible, maintainable applications that are easy to test without monkey patching half of the universe. And personally, it's been a pet peeve of mine, yes, another one, for many years to observe a kind of anti-intellectualism in the Python community around these topics. Bring up decoupling and people scream Java at you. Or they start reciting the Zen of Python with glassy eyes without actually understanding what it's about. Publish a dependency injection framework and you're a part of the Spring industrial complex. Also, the aforementioned services that I kind of announced at PyCon UK 2 years ago just crossed 4 million monthly downloads, so thank you, PyCon UK. I'm sure it's just you. So there is no Python inherent reason for this to be true. Only cultural. Go's type system is a joke compared to Python's. We've had generics way before them, and they don't have a way to explicitly handle nil in the type system, which for me is the main reason to have a type system in the first place. Java had to steal data classes from us, and C++ apparently has modules now. There's nothing systemic missing in Python, the language, that stops us from building maintainable complex software systems. There might be pieces missing in the ecosystem, but that's a consequence of the culture, not of the language. Now, some of you might be wondering what I'm even talking about, because we've got plenty complex software in Python. Just look at PyTorch, for example. Well, I don't expect you to read it. I'm just trying to impress on you the code statistics of PyTorch. It took 90 seconds to even git clone it over a 250 megabit connection. And it's 10,000 lines of assembly code alone. That's probably more assembly code than everyone in this room has written in their lives altogether. And clearly, this is very complex software. It has 2.7 million lines of code. But the thing is, there's many types of complexity. PyTorch is clearly a very complex project that is also famously complex to build. So when we talk about complexity, we must also specify what kind of complexity we mean and through what lens we are looking at Python software development right now. For example, we spend a lot of time talking about software design. How do you structure classes, functions, and the data within a code base? If you heard about clean code, the solid acronym Gang of Four, or composition over inheritance, this is what it's about. I guess you could call this programming writ large. And this is also something I consider myself rather bad at. When I see some clever algorithm, my eyes just glaze over. Like, I spend a lot of time to keep my code as simple and straightforward as possible, even if it takes more lines of code than it has to. After all, I am not playing code golf. Like, there's no trophy for me if I save a line somewhere. But on the other hand, I have a lot to lose if I can't decipher the business logic of my program a year later. And fortunately for me, the majority of work nowadays is not inventing cool new algorithms. And those who do usually put it on PyPI, so I'm fine. And by nowadays, by the way, I don't mean now with AI. I mean past 20 years, basically. The majority of work is gluing things together so they stay together and that you can glue more things on top of that without gluing your hand to your face and producing a big ball of mud. And that takes us to software architecture. Software architecture is about how you organize and govern modules, layers, and the interactions between all of them. How do you grow an application while keeping it changeable and understandable? This is where terms like clean architecture, or layered architecture, hexagonal architecture, or ports and adapters live. This is where command query responsibility segregation or event sourcing are trying to help. This is where the question is answered. How can I send out an email to a customer after they place an order without coupling my order business code to SMTP implementation details? And pains like this are often tried to be solved using historic mistakes like microservices, in the hopes that if you put enough network between classes, they somehow become less coupled. How has that worked out? Which takes us to system design, which is about how you assemble and orchestrate services, infrastructure, and external dependencies to deliver an overall product, ideally at scale, or to make it short, Kubernetes and Kafka. This lens is not interesting for this talk at all because it's not about languages at all. It's about just something exposing a port and a load balancer sending data to that port. So we are not going to talk about that. But of course, there's a lot more lenses. Like software design alone, there's a gradient of lenses you can have. Or you can go deeper than our higher level languages. Like, for example, there's the demonic Pablo lens, where you are using illegal languages, performing unspeakable rituals to allow you to be a release manager for Python 3.10 and 3.11, replace the REPL, give bananas introspection powers to async I/O, and write mind-boggling software like PySec or Memory, where my mind refuses to even try to comprehend how they work. But I generally recommend to stay away from this if you cherish your soul. But for those who do, worship. But what I want to talk about is the middle part. And I'm going to claim that this is a blind spot in the Python community. I'm aware of exactly 2 books on this topic. One is Sebastian Buczynski's Implementing the Clean Architecture, who was also at the fateful open space. And the other one is by our very Harry, and the sadly very reclusive Bob that I'm still not convinced actually exists. Until proven otherwise, to me, it's just 3 Harrys in a trench coat. Also, just look closely at him. I am no fashion expert, but this t-shirt does not scream, I've sold millions of books to me. Which is a bummer, because the pain from a bad architecture is something every single one of you has encountered. I guarantee you that. Even if you started writing Python last week, and welcome. Maybe you didn't realize it's caused by a bad architecture. Maybe you just take the pain for granted. It just happens if your software is growing. But it's not. But we've all ended up in highly coupled code bases where adding a single feature touched 5 files in 5 directories and caused 6 merge conflicts. So I think we can and should do better. And first, we need to identify where this culture is actually coming from, because it is not inevitable that an interpreted language like Python ends up with so little content on these topics. Prolific thinkers, speakers, and writers like Kent Beck came from Ruby. So thinking, writing, and speaking about software architecture does not inevitably lead to bean factory, 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 factory. And we should not allow our fear of becoming Java stop us from raising the ceiling on what kind of applications should be written in Python and are known to be written in Python. But there's a bit of a generational trauma in the Python community that is so ingrained into us that we don't even know where it's coming from. It's like a family trauma. Many of us old-timers in the community did come, in fact, from Java, and we just didn't want to end up with another Java, just without the curlies. And the standard library logging module always served as the constant reminder of the dangers if we sleep on our watch. So, firstly, I'm hearing Java is kind of good nowadays, so that particular conversation stopper maybe has lost some of its power. And secondly, fear is a poor guide. And I've seen concepts ignored and dismissed as unPythonic just because they smell too much of enterprise patterns. For example, how many of you know at least of this book? That is heartwarmingly more than I expected. I kind of expected only my beer buddies. So, for those who didn't, it's maybe 20% of hands went up. Domain-driven design is probably the biggest movement to improve how we think about the architecture of complex applications. It's less about handing you predefined patterns and more about how we approach software design in general and how we talk about that. So it's by definition platform independent, even though the examples are of course in Java because the book came out in 2004. But the only weird thing about it is the community a little bit, because many conference talks start with something like, what I think Eric Evans meant by this in the blue book is X, Y, and Z. And they somewhat resemble Bible study. But the only reason I'm bringing it up is that when you search for books or watch their conference videos, Python is almost completely absent from the community. And the least likely language has a front row seat, and you'll never guess which one. It's PHP. And I can only guess for why that is. I mean, one of the reasons usually that someone charismatic just brought it there. But my best theory is that they are so used to being the punching bag of programming languages. You may remember the blog post about how PHP is a fractal of bad design. And they are just used to work around the limitations of their language. And they are grateful for anything that helps. And our language is also limited when you go to the complex applications. So in short, there's less conceited dogma around in PHP. And we, on the other hand, are used to our beautiful, elegant language that everybody gushes over. Just like the elves of Lothlorien, we are playing our harps and we use terms like Pythonic or unPythonic to end conversations. And I'm so sorry, I swear this is the last AI slop in this talk. I actually have a subscription for stock material, but turns out they did not have elvish Python programmers playing the harp. I should get a refund. But I have the feeling that that attitude might have impeded our intellectual growth as a community in some areas. And to be clear, I am absolutely not saying everybody has to start doing DDD right now, especially I don't think it makes sense in science at all. We don't need a new dogma, but we need more conversation at the architecture scope. And it's helpful to look what others are doing, even if we decide to dismiss it based on facts, not on vibes. So let us at least fight over these kind of things as fiercely as we fought over single versus double quotes. And the beauty of these discussions is that we are not adding anything into other people's ways. Python is still fine. I'm not asking for language features at all. I'm not asking for Python to become more complex or harder to teach or learn. Python, the language, is not holding us back. It's about having an easily discoverable answer to why do I have 5 files called users.py in 5 directories. And why do I have to change all of them whenever I want to change anything about users? The answers, by the way, are lack of cohesion and vertical slice architecture. Or to put it more folksy, things that change together should live together. Now, I also think that some of the resistance comes from a place of discomfort. We really want to be able to define every entity exactly once. and use the same class in the front end, in business code, and in a database. And when then some weird dude with a Czech German accent comes around and tells you in broken English about design pressures and how they negatively affect your code, it's more convenient to say something empty like keep it simple, you ain't gonna need it, or mumble something about something be Pythonic or not without actually engaging the topic or making an effort to understand what is going on. And advanced software architecture often leads to non-idiomatic framework use because maybe frameworks nowadays are optimized for ease of getting started or to look really good on slides and not for the ease of scaling project out, which is kind of fine because many more people will start using them than will write big applications in them. So we need to accept that if you're growing, that you cannot write the same cute code you used to when you started a project. Architecture patterns are usually about making things more complicated locally for the payoff of less complexity globally, which of course is a trade-off. And whether this trade-off between local and global is worth it depends on you and your goals and your team, your trajectory. But it is a trade-off that I don't think enough people are making consciously. The thing is, we can't pretend that more complex applications are just another shiny PyPI package or feature away. An application that just lists a bunch of objects from a database and allows you to change some attributes on those objects and automatically saves those changes back to the database has very different needs than a payroll system that needs a full audit log and where every bug means that someone can't pay their rent at the end of the month. But back to EuroPython. After the conference closed, some of the guys from the photo hunted me down again and asked me how can we fix this, with this being our engineering culture in the Python community. Somehow, by being one of the few people talking about this stuff, I've become the spokesperson and leader of the engineering rebellion without ever asking for that. Clearly, it should be Harry, not me. But they wouldn't listen, and Harry is hiding. Yeah. But I hope that I have started some thinking and conversations today. And what I told my literal followers back in Prague is that we need to show up and show what's possible and focus on solutions to pain points that we know that people actually have. My rooms, when I'm talking about design pressure, were standing only, both in Pittsburgh and in Prague, despite being somewhat countercultural and kind of obscure. So there is a hunger for this kind of content. People are uncomfortable somehow in their gut feelings that something is going wrong. So if you, any of you, yes, I'm talking to you, have earned knowledge about these topics about these kind of things, please do share them, write about them, give talks about them, produce TikToks about them, for all I care. Every medium is fair. And I don't know if this is how we win, but I sincerely hope that this is how we push the Python community forward towards an even brighter future where we can attend cross-platform conferences without being made fun of. So, what is even my point? I have even three. I want you to stop being insecure about Python. There's many ways to write Python, depending on the problem you're solving. None of them is canonical. This is our superpower. This is not our weakness. And I don't want you to just open your heart to it. I want you to open your minds to it. Could it be that you consider a certain style of Python the only Pythonic Python? But again, we don't get to decide what's Pythonic. Only Guido does. And as far as I know, he's not here. Could it be that you are set in your ways? Try a new style. Try static typing. Try async. Try setting the rough linter to all. And ponder the ostensible errors it's reporting. That's what I do. And I learned a lot of them, especially like performance hacks. It's pretty good. And I do have a very long list of ignores for each of my projects, but I know exactly why I have disabled those warnings. Options have costs. Forcing a whole community to make a decision or implement another special case might not be worth the upside of some of us pressing fewer keys. Let's take our responsibility more seriously and guide people with better tools and better documentation to good solutions, to simple solutions. Let's focus on horizontal graduals instead of vertical instead of horizontal. God. So this is about unnecessary forks in a way, not about raising the barrier of entry or lowering the ceiling. Quite the opposite. There's many people working hard on making simple things easy, and this is very important work. I love the new exceptions. But let's also put more work into making more complex things possible. I want you to question dogma. I want us as a community talk more about software architecture and how to push Python forward. Because thinking about architecture does not make you an architecture astronaut. It's bad architecture that's caused by lack of education and understanding of the trade-offs does. And you have to learn a lot until you can tell what's good or bad, simplistic, adequate, or over-engineered. And that's all I've got for you today. Thanks for humoring me. I've got all the socials, but nowadays it's so many that they don't fit on a slide anymore, so come to my homepage and pick your favorite. I will point out, though, as Mark already did, that if you got addicted to my sexy Czech German accent, you can get more of that on YouTube. It's mostly about UV these days, because it's the only thing people watch, but I try to smuggle in videos about engineering and DevOps now and then too, and then just yell at my viewers to watch them in my UV videos. Of course, since this talk was meant to start conversations, come and talk to me. I'll be here for the whole time. Let's start a rebellion together. Some topics I will only discuss over beers, though. And since I have still some time, logic at institution time is a sin. Thank you for attention on this matter. So, all right. Now I'm done. I'm just gonna melt to a puddle of goo. Thank you very much.